Hi guys, welcome back to the course on core Python programming. So in today's video we are going to talk about sequence data types. So there are 6 different types inside sequence data types. First one is a string, then bytes, then byte array, list, tuple and range. So let's take a look at the string data type. So str means string, okay? It's short form of string is str, and a string is nothing but a group of characters. Any characters you see on the keyboard that is typable, it is considered as a character, and if you represent them inside a double quotes or a single quote, you can consider them as a string. And for example, here you can put some parentheses, if you can put some parentheses here, or if you want to put some star symbol here, anything inside the double quotes or single quotes is considered as a string. And when you try to print them, here we are printing abc, here printing abc and xyz, you are getting the output here, right? So this is the output. So that's all about the string data type. And one more information about string data type is you can also use triple double quotes or triple single quotes. So why we use that is because sometimes if you want to use single quotes or double quotes inside a string, for example here I am putting jcg tube inside quotes, right? So if you want to use quotes inside and you want to put them, you want to display it or you want to print it out, then you gotta use triple double quotes or triple single quotes. So when you print it out, you see this output here, see this output, right? It is showing the single quotes here and showing the double quotes, because if you want to show them in the output, you gotta use triple double quotes or triple single quotes. So that's all about string data type. Now let's see the bytes data type. In bytes data type, it's only consists of numbers, so only positive numbers from 0 to 255, and 255 is inclusive. You cannot store negative numbers. And if you like declare, or if you create a byte data type and you add values into it, which we'll see in the next example, you cannot modify them. So just remember that bytes data type is only for storing numbers. It's only for storing numbers, that is from 0 to the range of 25, and they cannot be modified. I'll show you they cannot be modified statement in the next slide. So here we are creating a list. So list is one of a data type, but first in the initial, like in the big, to convert to bytes, we first make a list and naming the variable elements. This list is stored in the variable called elements. So in this list I'm adding 10, 20, 30, 40, right? So that is the numbers 10, 20, 30, 40 are stored in elements, and I'm making another variable x, and I'm converting this list, this list, right? I'm converting it into bytes. So this is the inbuilt function that is created by the Python developers in order to convert any data which is given inside the parenthesis into the bytes data type. So here the elements, which is the list data type, is converted to bytes data type, and you are trying to print out each element. So this is the 0th position. So in computer, any starting where memory space is considered as like 0th position. So the index of this is 0. It's called index. It's called index 0. This is index 1, index 2, index 3. So that's why when you print x of 0, right, x of 0, you're printing 10. So you're getting the output 10. In when you're trying to put x of 1, you're printing 20, x of 2 is 30, x of 3 is 40. In the next slide I'll show this indexing. So in this concept of index, you see, let's consider that I created a variable and I'm storing PROBE, like for example, let's consider s is equal to, just consider as a list, I'm storing p like separately, p r o p e, and when I write the statement in the Python, the memory is allocated like this. Just consider as a box, like a rectangular box, 1 2 3 4, and p r o b e is stored. And so this is the index 0, index 1, index 2, index 3, and index 4. And if you want to print the last element, instead of typing x of like, instead of print here, I took the example s, right? Instead of s of 4, I can use print s of -1. So what negative minus digit means, it goes to the end of the list. So -1, so it goes to e, and when you, instead of -1, if you put -2, it's gonna go to this position, right? And if you wanna print this o character, you can use print s of it's actually in square brackets. Remember, it's actually in square brackets, s of 2. So in order to address an index, you have to use the square brackets. So I can use 2, or I can use print s, just consider s is equal to s of -3. So both are same. So if you go from left to right, you use positive numbers, and if you go from right to left, you use negative numbers to address the position. So in 0th position p is stored, that is in -5th position p is stored. So that's all about indexing. And in the next slide, we are trying to modify the value. So here the element list data type, I'm storing 10 20 30 40, and x is equal to, I'm converting this list statement into byte statement and passing the variable elements into the function bytes, which is an inbuilt function, and here I print it. So here I actually printed 10. So x of 0, 0th position is x of 0, in first position is x of 1 is 20, in x of 2 here is 30, and x of 3 here is 40, right? So that's all about indexing. And here one important fact about bytes data type is, here if you see x of 0 is equal to 5, I'm trying to modify this value. So here x is equal to bytes of elements, I'm trying to modify this value 10. So I'm trying to change 10 to 5. So but it doesn't happen because it becomes an error. So in bytes, when you declare a variable which is a bytes data type, you cannot change the value. So it's almost like read only. Once you declare and store or like store the data, you cannot change those values. And only numbers can be stored in bytes data type, just numbers from 0 to 255. all right, so let's go to the next slide. In next slide, we are going to talk about byte array data type. It is similar to byte data type, the before data type, the recent data type which we saw, byte data type. The only difference is that byte data type can be modifiable, so it won't show errors if you are trying to change a value in between. Here we'll see an example. So here, same example, elements, I'm creating a list and I'm converting this list into byte array by using the function byte array, which is an inbuilt function, and inside the parenthesis you pass this variable elements, right? And once this statement is executed, this list data type becomes byte array data type. And then I'm printing x of 0, 0th position, first position, second position, third position. Always remember, the indexing starts from 0, so addressing starts from 0. and x of 0, so once I print it, it becomes 10, 20, 30, 40, and I'm x of 0. What is x of 0? X of 0 has 10. So x of 0 has 10, and I'm modifying the value to 5. So now after modifying the value to 5 and I print it again, it becomes 5. It's not showing any error. So the only difference between byte data type and byte array data type is that byte array data type is modifiable. Alright, so and also only numbers can be stored, no negative numbers, and numbers between 0 to 25, sorry, 255 can only be stored in byte array data type. Okay, now let's move on to the next next slide. Next we are going to talk about list data type. So in the previous example we saw, right, the list we are trying to make. So here you see this is a list, right? So we'll see the example again. And list data type is used for representing different data types in a same variable. So in previous examples you see only numbers can be stored, so only numbers that is from 0 to 255 can be stored. But in list data type you can show the example, you can store any data type. You can store int data type, negative numbers, you can also store float data types, you can store strings, you can store any data type inside list data type. So we are creating here a variable called list example, and it is enclosed in square brackets, and if you want to store a value you have to open up and close the square brackets, and inside that you can add any data as you want. We'll go to the before slide again. You can, so here you see you can store different types of data. It's just a collection of group of elements, and you can dynamically grow in memory. For example, if you see in the language like C and Java, you have to initialize, you have to predefine the size of the array. So you cannot add any more arrays. If you want to you cannot add any more elements into the arrays. So the memory allocation is fixed. You're fixing it in before you add any data, you're fixing the memory size of that array. But in the case of Python, you can dynamically grow the memory space. So for example, in this, if I want to add more data types, I can just add the statement called, I'll make a separate video on the statement, but I'll just show. In order to add more, I can just use list underscore example dot app append. Maybe if I want to add the rest of my name, Joseph. So when I put list example dot append Joseph, what happens is that the Joseph, this name will be appended, and this will get stored inside this data type, this list data type that is inside this variable, and then the new list will be of the form the same thing. The same values will be there: 10 minus 20, 15.5, then Jason, then Carter, and then this also will be added, Joseph. So in case of Python, you can grow the list to any maximum size as you want, as long as you have memory left in your computer. And so the thing is, you're representing list using square brackets, and you're separated by commas. So elements are separated, so the 10 and minus 3 is separated by commas. So that's how you separate two different values. And I'm trying to print the list, print this variable, and trying to print the data inside this variable, and here you see it's printing, right? So that's how you print a list. Just use the print function, and whatever the variable you have used, just pass into this function and print. And as I told you, index, what is list example of 2? So this is 0th position, this is first position, this is second position. So the float value 15.5 is being displayed. So that's what is this. Indexing means list example of 2. So it goes to the second position, that is skips 0, it skips 1, and the pointer goes to second position and displays it. Okay, next data type we are going to see tuple data type. So tuples are similar, it is similar to, so see, it's similar to list, and it also can contain any types of data. You can add strings, you can add characters, you can add boolean values, you can add float, you can add int, and they are represented by parentheses. So in list we saw that it is represented by square brackets, right? So in list it's seen that it is represented by square brackets, and in the case of tuples it is represented by parentheses, and tuples cannot be modified. So as we know, the byte and difference between byte and byte array is that byte arrays are modifiable. The same difference is there in list and tuples. So in tuples the data cannot be modified once it is initialized in the sense you store the data, and after that you're trying to modify the data, you cannot do it because the tuples are meant for that. It's only meant for read only. As once you initialize it, you cannot change the data what is inside it. And the next example we'll see an example. Next slide we'll see an example. So here I'm creating a variable tuple example, and the data type of it is tuple, and here I'm showing same variables same data I'm storing 10 minus 20 15.5 JSON Carter strings I'm storing, and I'm printing it. Same thing will be printed, and you see it is also printing in tuples, right? So in the previous example also, in the list data type you saw that it is printing the output in square brackets. In the case of tuple it's printing in parentheses, right? So, and also again the indexing is same for any data type, 0 1 2 3 4. So I'm printing tuple example of the index 2, so it goes to here and it prints 15.5. and I'll show you in the next slide if you are trying to change the value what happens. So in this case I am the same example, a tuple variable which is of that, of course the data type is tuple, and printing the tuple, it's printing, I'm printing the second variable, the second index, which is 0 1 2. so this second index I'm printing and it's coming 15.5, and here I'm trying to modify this value. So tuple example of 0, what is 0? This is 0, right? This is 0. I'm trying to modify it and make it 1. So according to tuples it is meant so that the values which are stored cannot be modified, so that's why it's coming error. See the error, the tuple object does not support item assignment, meaning you cannot modify it. So in the next example we see for loops. I'll make another video also for loops, but for this example it's necessary just a small intro into for loops. And for loops are used to iterate through sequence data types. For example, here's like same tuple example where I'm storing these values. So instead of printing like x of 0, x of 1, like in the previous example, instead of printing like x of 0, x of 1, x of 2, x of 3, you can use for loops. So inside using for loops you can go through one element through you can go through first element through to the last element through for loops. So what happens in for loop is, for I in tuple example, when this statement is encountered, the pointer that the compiler goes to 0th position. So it goes to 0th position, gets this data and it stores in the variable I. So consider there's a box and the variable, the name of this box is I. So for I in tuple example, it goes to the 0th index and it stores the value 10, and we are printing I. So what is in I? 10. Now after this statement is printed, it goes back to the loop. So it goes back to the loop. Now the compiler goes to second position. Sorry, this is not second, it goes to the first position, so 0 1. So after for 9, initially it was 10, right? So after the for loops, first for loop is executed, after this print I is executed, see 10 is printed, right? So 10 is printed. After this, after that, no function is there or no statements are there, so it goes back to the for loop, and now it go the pointer or the compiler goes to the second, meaning the first index of the tuple, or it can be list data type, any data type, or anything that you have like stored using commas. It You can use for loop to iterate through these items, and now that the compiler goes to the second position, the value -20 is stored in I. So this 10 is gone, this 10 is modified into -20. So now if we print I, what happens? -20 is printed, right? Now again, after this statement is printed, it goes back again into the for loop. Now the compiler goes to the second index, in second index 15.5, and then what happens in after goes to second index is that this -20 is replaced by 15.5. so 15.5 is stored in the variable I, and we are printing I. So what I has now? I has 15.5, right? And again, after printing this I, it again goes to for loop, and now it goes to the third index, that is the string JSON, and now 15.5 is replaced by JSON, it's string, and I, now this is stored in I, right? So now printing I, it prints out JSON. Same thing happens for Carter. This loop goes back in, and now it goes to the fourth index, fourth position, right? And it cuts JSON, and now it stores Carter, and after that, end of line. It would be actually compiler sees it as /0, right? So /0 means end of line. So once the I, this variable I encounters and it stays at /0 after Carter is cut off and it stores /0, it means it is end of line, and the for loop gets over, and it comes out of for loop and goes to the next line of the code. All right, I'll show that again. Once the compiler reaches the fourth, and after executing the fourth index, in the I variable /0 is stored, and /0 means it is end of line, EOF, end of line, meaning there is no more data inside the list or whatever data type you are using, and it comes out of the loop at that time and goes to the next function. In case if you have something other like print hello, it prints hello, and that's how it comes out of the for loop. It uses the symbol /0, meaning there's no more data inside the data type. Now let's see the last data type, that is the range data type. Range means what? It's range of numbers, right? So when you represent like a range and inside the parenthesis 10, what happens is values are inside the R. The values which are stored inside the R ranges from 0 to 9. So all the numbers between 0 to 9 are stored. So in case if there is a way n inside it, means 0 to n minus 1, these numbers are stored inside R. So stores value from 0 to 9. In the case of this example, 0 1 2 3 4 5 6 7 8 9. So all these values are stored inside the variable R. So that's what you use for range. So instead of just typing 1 2 3 4 5 inside the list, you can directly use the range function, which the computer itself creates the numbers from 0 to 9. And in the next example, in case if you don't want the compiler or the number to start from 0, you can specify it. So in this case, you want to start the counting from 30 and it should end at 40. So you can put here the starting number, and here you can put the ending number, and here is you can use it to increment by how many steps the number should increase. So when you put 2, only even numbers are printed. So 30 now plus 2, 30 plus 2 is 32, and 32 plus 2 34. So till 38 is printed, but 40 won't be printed because the ending number won't be printed till the number before 40. So till 49 will be printed, but in this case we are incrementing it by 2, so that's why only till 38 is printing, right? And so in this for example, in this case, instead of 2, if I put 1, so all the numbers from 30, 31, 32, by default, if you don't give this value, the computer sees it as 1. Okay, by default the value is 1. So in this case, if you're putting 1, 31, 32, 33, 34, 35, 36 till 39, it will be printing. So for example, if you're instead of 2 you're putting 3, so what happens is 30 is printed, then 30 plus 3 is 33, then 36 is printed, 37, 38, 39 is printed, and after that's it, 30, 33, then another 6, meaning plus 3, so plus 3, 36, 36 plus 3, 39. So these numbers are printed. So you can put any number here, so that many steps will be increased, that much numbers will be added to these values. And also if you wanna use minus, you can also use minus number. Okay, so minus 2 means in this case I have to use 40 and 30. So remember, I'm using 40, 30 and minus 2. What happens in this case is 40 will be printed, then 38 will be printed, then 36 will be printed till 32. So 30 won't be printed because that's the last number or the ending number. So this is how you print the reverse of the range by using a negative number. So that's all about range. Now in next program we'll see creating a list using numbers. So here you're making a range data type. So I'm making a variable list lst, just a random variable lst, and I'm creating a data type range is here 10. So numbers from 0 to 9 will be stored in range, and I'm converting this range data type to list data type using the function list. So inside this parenthesis you're passing this function range 10. So what happens is the range data type is converted to list data type. So when you print list, this is getting printed. So that's how you create a list using range of numbers. So if you wanna list 0 to 9 inside a list, instead of just typing 1, 2, 3, instead of that you can use the short form to create numbers using the range data type and convert that into list using the list function, using the inbuilt function, and the print the variable using the print function, and the print happens. That this is the output. In this next slide I'll just show you the memories taken by each data type. Bool, we know it's only 0 or 1, so it's in 1 byte, and in normal int cases it can be of 2 bytes or 4 bytes, right? So int data type occupies around 2 bytes or also 4 bytes depending on the size of the number. That much bytes are occupied by the memory in case if int data type is declared or the code is there in the program. Next we'll see the float data type. Float is actually start from it might be 4 or it can be 8. Most of the time it will be 8 bytes. So in case you're making a big decimal points, it will be of 8 data type 8 bytes, and it can go up to 16 bytes also. Complex data type usually takes 24 bytes. It can take 32 bytes also, no problem. String, we know, like it depends. If you're putting only like this, if you're storing only the character s, it will take 1 bytes, or if you're putting st, it will take 2 bytes because each character is 1 byte. T is 1 byte, and if I'm typing JASON, that is 1, 2, 3, 4, 5, right? So it will take 5 bytes. So that's why they haven't mentioned. So it can be dynamically grown also. Even list also, list data type Also, the bytes cannot be like, you don't have to like know the bytes, because it depends, right? If you're storing one int variable which is of size 2 and another float variable which is of size 4, so 2 plus 4 is 6 bytes. So this 2 is int data type size and this is float data type size. So 4 plus 2, 6 bytes. So this size of this list will become 6 bytes. And the case of range also same. Like if you're storing from 0 to 10, 0 to 10, 0, because it's int, it will take 2 bytes. So 2 into, and that'll be 0 to 10, right? So that'll be 10 digits. 0 to 10 means, that means 0 to 9 according to the range data type. That'll be 10 digits, right? So 2 into 10, that'll be 20 bytes. So the function range, or the data type range of 10 will occupy 20 bytes. All right, so that's all about the size of each data type. You don't have to know, just remember it. I mean, don't remember it, just know it. You don't have to remember the size of bytes and all. So that's all for this video, and see you in the next video.